Why do materials fail? By brittle versus ductile fracture. Imagine a glass window shattering into sharp pieces with a single tap, or a piece of metal bending without breaking. These are examples of how materials can fail in very different ways. Today, we're exploring why some materials break suddenly and others give warning signs before they fail. The key lies in whether they fail by brittle or ductile fracture. Materials fail by brittle or ductile fracture mainly because of how they handle stress and deformation. Ductile materials can stretch and bend a lot before breaking. They absorb energy as they deform, which makes them show visible signs like necking or thinning out before they finally fracture. This slow crack growth gives engineers time to notice and prevent failure. The fracture surface in ductile materials looks rough and often has a cup and cone shape. Brittle materials, on the other hand, don't stretch much at all. They can't deform significantly and tend to break suddenly without warning. When they crack, the failure happens very fast, often along straight lines that look shiny and flat. Because brittle fractures happen with little to no deformation, they hide the signs of failure, making them more dangerous in many situations. The main reasons for these differences come down to atomic and microstructural behavior. Ductile materials have atomic bonds that allow atoms to slide past each other easily, which enables plastic deformation. Brittle materials have stronger, more directional bonds that resist deformation but crack when the stress gets too high. Energy absorption is another factor. Ductile fractures need more energy because the material deforms plastically, dissipating energy before breaking. Brittle fractures need less energy, so failure happens quickly once a crack forms. Crack growth also differs. In ductile materials, cracks grow slowly because the material can deform and blunt the crack tip. In brittle materials, cracks spread rapidly without deformation, leading to sudden failure. Understanding these failure modes helps engineers design safer products. Ductile materials are often used in load-bearing structures because they give warning signs of failure. Brittle materials are chosen for hardness and strength but need careful handling to avoid sudden breaks. In essence, whether a material fails by brittle or ductile fracture depends on its ability to deform, absorb energy, and how cracks propagate through it. This explains why some failures happen gradually with visible signs, while others occur abruptly and without warning. Recognizing these differences helps us prevent unexpected breakdowns in everything from bridges to machines.